welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். Vari Medical Academy சார்பாக இனி வரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய faculty members லைவ் வீடியோ ஸ்ட்ரீமா உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் Vari Medical Academy சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க, உங்க ஃப்ரெண்ட்ஸ்க்கும் ஷேர் பண்ணுங்க, அவங்களுக்கு யூஸ்ஃபுல்லா இருக்கும். Thank you.
My name is B. Mahanadhi. I am a physics faculty in Vari Medical Academy. Today I will explain for the refraction. What is the refraction? If your refraction is where we will use how to the change of refraction. If you any one medium to another medium, the incident light ray is passing, what happen, how much the deviation and everything now we will discuss. First concept is the refraction. Refraction is the if you any incident light ray is one medium to another medium is passing, that time what is the change means that is only applicable for the in refraction. If you any one medium, that is rarer medium or denser medium, one medium to another medium is changed time, the incident light ray of path direction is changed. How to the change of the incident ray path direction is called a refraction. Now if you take one of the rarer medium and denser medium, now this is the denser medium, now another one is the rarer medium. The incident light ray is falling on the any one of the another medium is transferred. Exactly center is the normal. Now the incident light ray is falling on the one medium. That time the incident light ray is some refraction means bending of curve. Bending. This is the incident path ray. This is the normal. Now incident ray and normal in between angle is the incident angle. Now the incident ray of path is incident path. Normal and refraction ray. Refraction ray is the means if you any rarer medium to denser medium, the incident light is passing time, the refraction ray is towards the normal is formed, but that angle is the refraction angle. But these incident ray and refraction base how to the change of medium and wavelength means first the normal of the incident ray to how to the denser medium of the refraction ray is possible means based on the optical density. If your optical density is different having means which one is the more optical density, which one is the less optical density is the means rarer medium. Rarer medium is the less optical density. Denser medium is the more optical density. Optical density is based on the refractive index. Now the incident ray and reflected ray is the we have based of the rarer medium and denser medium. If you suppose denser medium to rarer medium is passing time, what happens? What is the Snell's law? Snell's law is the if you any incident ray is falling off the one medium to another medium is transferred, first one medium is the this is medium 1, this glass is the medium 2. This glass of the refractive index is different, this air of the refractive index is different. This refractive index is what is the relation with respect to means mu to 1. the refractive index is 2 with respect to 1, means the refractive index second medium with respect to first mediums. Mu2 by mu1. Now what is the angle of minimum deviation? How do we can find out the angle of minimum deviation? Means now first I will consider the rarer medium to denser medium. Rarer medium to denser medium, if any incident light ray is passing time, how the change of the angle of minimum deviation means coming to. Angle of minimum deviation means the reflected ray and the incident ray of path in between angle is called angle of minimum deviation. Once listen, the incident ray of path and the refraction of ray in between of the angle is called angle of minimum deviation. This angle of minimum deviation, how to we can find out means the incident angle is equal to the total of the angle is the equal. Now same the angle we need, angle of minimum deviation I need means the angle of minimum deviation is the totally what I minus r. This remaining angle is called a minimum deviation. Minimum deviation del equal to I minus r. If you suppose the denser medium to rarer medium is transferred, what happened the angle of minimum deviation? If you denser medium to rarer medium, the incident ray is transferred means the refraction ray is away from the normal is moving. This ray is the normally away from. This ray is called a emergent ray. Same, what is the angle of minimum deviation? Angle of minimum deviation del equal to. Now here say the refraction ray denser medium to rarer medium time, the refraction ray is the, this is the totally, but the incident of path, this one means the emergent ray and the incident of the path in between is angle is called angle of minimum deviation. Now this one, the angle of minimum deviation is r minus I. Refractive index of the refractive index in vacuum. Refractive index is representation of the mu in vacuum is 1. The refractive index is the units is no units. No units. But refractive index in air is 1.001. If your refractive index of the water is 4/3, refractive index of the glass is 3/2. These all are the constant value of refractive index. Snell's law. Continuously means the Snell's law is the refractive index and multiply with of the sine of the incident angle of in rarer medium, same as it is the refraction of the angle of sine angle, the product of the denser medium means generally the refractive index into sine I is constant. But first here rarer medium and denser medium having, and denser to rarer is possibility is transferring. The rarer medium to denser medium time mu1 sin I is equal to mu2 sin r. I is the incident angle of the incident ray, r is the refraction angle of the refraction ray. Now sin I equal to mu2 sin r having. Now sin I by sin r is equal to mu2 by mu1. This is the Snell's law. This Snell's law, if you any rarer medium to denser medium, if you now A to glass or A to water, whatever is transferred means air is the refractive index is 1. That one also sin I by sin R equal to mu2 means mu. If you any rarer medium to denser medium, rarer medium is the now air is transferred, air to glass is transfer time, the refractive index is mu equal to sin I by sin R. Now this refractive index, what is the base and everything is the formulas, means refractive index is mu equal to speed of light in vacuum by speed of light in medium. Means mu equal to C by V. But we know electromagnetics, C equal to 1 by root of mu naught epsilon naught, V equal to 1 by root of mu epsilon. This mu means this is permittivity of medium. Now mu equal to C is the 1 by root of mu naught epsilon naught by 1 by root of mu epsilon. Means already we know epsilon R is equal to epsilon m by epsilon naught, means mu equal to root of mu R epsilon R. Relative permittivity. Now the refractive index is depend on the refractive index depend on if your temperature is increased, the refractive index mu is decreased. But if you rarer medium to denser medium, the wave one medium to another medium is change time, one medium to another medium. That time the frequency is same. The color also same, and phase angle also same. Phase is same. What is the variation of the incident ray is one medium to another medium transfer time? That time majorly is the amplitude is changed and wavelength is changed. Amplitude and wavelength is changed. Majorly, what is the lateral shift and what is the normal shift? Now lateral shift. What is the lateral shift means? The lateral shift means the incident ray is one medium to another medium is transfer time. How much the shift direction is changed means that is lateral shift. Now another one denser medium having and the normal is exactly of the center. The incident light ray is falling of the medium, rarer medium and denser medium. Now normal is continuously extension. The incident ray path is continuously extension. Now rarer medium to denser medium passing time, the incident ray is towards the normal is formed. The refraction. This angle is the refracted angle, but the refraction ray and the incident path in between exactly some perpendicular angle is maintained. This perpendicular distance is called a lateral shift. Now the incident ray and normal in between angle is incident angle. Here at origin point I will choose point A, here B, here C, here D. Now coming to point. Here A, D and C, one of the triangle. This angle is called a angle of minimum deviation. This angle of minimum deviation is what? I minus R. Now what is the Snell's law? Snell's law is mu equal to sin I by sin R. Snell's law is normally mu 1 sin I equal to mu 2 sin R. Now triangle ADC. Triangle ADC. Triangle ADC. This angle is a angle of minimum deviation. This ray is the incident ray of path. Now what happened? The sin theta means sin I minus R. Why? Means the angle is the deviation angle is I minus R. The sin theta is generally opposite by adjacent. Opposite by hypothesis. Opposite means CD by hypothesis is AC distance. Sin I minus R equal to CD. CD is the distance is called a lateral shift. Lateral shift by AC. Now triangle ABC. Triangle ABC, comma. Now cos theta means what? Cos R equal to, cos R means adjacent by hypothesis. Adjacent is AB by hypothesis means what? AC. AC equal to AB by cos R. Now AB is the denser medium of the distance. This denser medium of the distance means I will choose thickness is T. Now AC equal to T by cos R. Now this is the second equation. Sin incident, this is the first equation. Now the thickness is the T of the denser medium. Now the AC is the, I will substitute here. This AC is the majorly the refraction of the ray. Now lateral shift is equal to AC into sin I minus R. Now AC distance is T by cos R. Lateral shift equal to T by cos R into sin I minus R. Now T is the thickness of the denser medium. Cos R, if you cos R, what happens? Sin I minus R, what happens? Means the lateral shift is equal to T by cos R into sin I minus R. Now we know the angle of the deviation is very small angle. Sin I minus R nearly equal to I minus R. Why? Means because sin theta nearly equal to theta. Now same, the cos R, cos theta is nearly equal to 1, cos R nearly equal to 1. Now I will substitute these values in lateral shift. The lateral shift is I is outside means Ti into 1 minus R by I means Ti into 1 minus 1 by I by R. Ti into 1 minus 1 by I by R is the refractive index. Now this is called a lateral shift.